Hi everyone. Today's lesson is a little bit involved with the number of things that we're going to do. And so we are going to learn to use the slope of lines, which we covered in the previous class, to determine if lines are parallel or perpendicular, or sometimes neither, depending on what it is that we got to see. So I really quickly want to talk about what is a line. A line is the set of all solutions, meaning points of a linear equation. So it's infinitely many solutions to a linear equation. And you know linear equations. Linear equations are any equation that can be written as y equals mx plus b, where m and the coefficient of y are not both 0. So m has to be a number. That's what this is saying. M is a number. And of course, we know that m is a number that represents the slope, and b represents the y-intercept, which happens to be a point. The x-coordinate of that point is 0, and the y-coordinate matches whatever this number is, if it's positive or negative. Slope-intercept form then helps us to graph. So we have reviewed this a couple times, and I know that you did this with Ms. Ferrer as well earlier in the year, that you start counting from you graph the intercept first. That's the very first thing that you graph on the y-axis. So it could be up or down, depending on where it is. And then you use the slope to count up and down and over. You do rise over run, right? Because slope is rise over run, to count from your starting point to then get a graph. So that's one thing that we've kind of talked about, right? With parallel lines are lines that aren't in the same coordinate plane as each other, and they never intersect each other. But they also have to have something in common with each other. And so I want us to explore parallel lines really quickly. And I want you to take a look at these lines that you have here, and let you know that all of the lines are parallel to each other. And I want you to take a moment to tell me what you think that they have in common. So let's take a look. Let's actually prove this. So I am going to take a look at the slope of each one of these lines. So for the blue line, from -3 to 0, I'm going to count up and over, my rise over run, and it looks like I go up 4 over 1. So this slope right here is equal to 4 over 1, which is the same as 4. Okay, let's take a look at the red line. In the red line between the 2 points, looks like I go up 1, 2, 3, 4 over 1 also. So this looks like it has a slope of 4 over 1, which is also 4. Now let's take a look at the green line. In the green line, I'm going to use red. Between the 2 points that are indicated, I'm going to count, let's see, 1, 2, 3, 4, 5, and over 1. So this slope is equal to 5. So these two lines right here, K1, right, and K2, are parallel to each other. So line K1 is parallel to line K2. The reason why they're parallel to each other is because both of them have a slope of 4 over 1, which is the same as 4. So parallel lines, what they have in common with each other is that parallel lines have the same slope as each other. And that was kind of tricky, right? Because that green line looked like it could have been parallel also because it doesn't intersect, but the slope is not the same. Perpendicular lines, on the other hand, they do intersect with each other. They intersect with each other once at 90-degree angles in the same coordinate plane. They also have something different in common. So let's take a look at these perpendicular lines. So if these lines are perpendicular, that means that they intersect each other at 90-degree angles. So each one of these angles is 90 degrees. Okay, let's examine the slope of each one of these. Okay, so I'm going to take a look at the blue line. And if I'm doing rise over run, my rise is actually negative. Do you see how I'm going down? And then my run is positive because I'm going over. So my rise is -3 because I go down, and my run, let's take a look at the run, is 1, 2, 3, 4, 5, 6, is +6 because of the direction that I go in. So for the blue line slope, so I'm going to use M, my slope is -3/6, which actually can be reduced to -1/2. Let's take a look at the other line. Okay, the red line. So for the red line, from the point A, I'm going to go rise. Right, there's my rise over run. And since I'm actually going up, and I go up 1, 2, 3, 4, 5, 6, I go up 6, and my run is 3. It looks like my red slope is +6. My bad. Let me erase that gibberish. My red slope is rise of 6, right? Because we went up 6. And my run was 3, which reduces to +2/1, right? Technically, which is the same as 2. I want you to compare the slope of my blue line and the slope of my red line, and I want you to tell me what you notice. What do you notice about the perpendicular slopes? You should have noticed that the slopes have the same numbers, but the numbers are in different places from each other. So for example, the 3 is on top and the 3 is in the bottom over here. And the 3 was negative here, but the 3 is positive in the bottom. The 6 was in the denominator, and then the 6 moves to the top. So what this is called, this has a technical term. Perpendicular slopes are opposite reciprocals to each other. What does opposite reciprocal mean? So opposite reciprocal, and I'm going to show you in the next slide, they have opposite signs from each other, and that's kind of what we saw, right? So they have to have opposite signs, and they are reciprocal, so the fractions kind of flip from each other. So for example, to find the opposite reciprocal of 2/3, 2/3 is a positive number. So the opposite of a positive number is negative, and the reciprocal is the flip of 2/3, which would be -3/2. So -3/2 is the reciprocal of 2/3. And those slopes would be perpendicular to each other. Opposite reciprocal of 3. 3 is positive. So that means the opposite reciprocal would be negative. 3 can also be rewritten as 3/1. So when I need to do a reciprocal or a flip, I can then flip it. So -1/3 is the reciprocal of +3. If I had a -1/2, right, this number is negative, the opposite of negative would be positive, and reciprocal would be flipped +2/1. So these are opposite reciprocals of each other, and perpendicular lines have opposite reciprocal slopes. So this is going to end part 1 of our lesson before we get into the examples.